Hey everybody. In this video, I think what I really want to do is just get down to some equation solving, and these will be linear equations. We haven't really solved a lot of equations together this year. We started off with sequences, and that's part of our curriculum we start with. But in this unit, I think what will fit in here is a good solid equation solving practice. And you've seen this stuff before, and I'm just going to go over it again. Maybe I can show you something a little new. I don't know. You can decide. I hope we at least get something out of this in terms of it being helpful for you in the future, because it's a very essential skill. You got to be able to solve equations in math to be successful in mathematics. All right. So what I've got on this slide here, or in this set of notes, and I think I've already shared with you, these are called properties of equality. Now, I'm not going to spend a ton of time on this, but I do want to point out, when we're solving equations and working with these equations, they represent not real numbers. And there's properties. So I want to go through these really quick, and these are shared with you so you can look at them on your own time. So there's a symmetric property. And that means this. If two things are equal, this is it in my words. If two things are equal, it doesn't matter which side of the equation they're on. If A is equal to B, then B is equal to A. And you guys, where does that bother me when people do stuff like this? Let me just show you. Here's where that property can be used. If I'm solving an equation, say 2x plus 1 is 5. That's also the same as 5 is 2x plus 1. Okay? You are allowed to switch sides like that. Don't change any signs or anything. That's like flip-flopping the entire equation. That is totally legit to do. Okay? So let's get to another property. This is a substitution property. I'm not going to show an example of this because I think this example here is pretty good. If A is equal to B, then A may be replaced by B in an expression. For example, in this expression right here, if X is 3, then I can plug X3 in for X. All right, that's just substituting things in. You're allowed to substitute. If they're equal, then they're equal. I mean, it sounds redundant, but believe it or not, it's important, okay? Additive inverse. Where do I use this? Okay, A plus negative A is 0. Well, here's a place where you might think of using this, and then it shows you that if you add anything to its opposite, it's 0. One way to look at this would be if I said x plus 4 is equal to 7. You could say, well, I'm going to say plus negative 4. Well, that doesn't look right. So a lot of people say minus 4, right? That's the same as adding a negative. That's removing it from this side. But you're doing the same thing to both sides, right? And that's one place you would use that. So x would be 3. Again, you can say plus negative 4, which is minus 4, subtraction, and that's how that property works. Or that's a use for that property. Not the only use, but that is a practical use of it that you're going to see us doing. Multiplicative identity. I don't think I finished this one. This is the multiplicative, or is it on the next? Oh, okay, it's down there. I'll try to format this a little better. Multiplicative inverse and multiplicative identity. Anything times 1 is itself. Okay? One place this annoys me is when people don't realize if I have the variable x here, well, not equal to anything. Say x, and I got 2x and 3x and so on. And I say, what are the coefficients here? And it's obvious the coefficient here would be 2, and this one would be 3, but a lot of people still understand this one isn't understood 1, because 1 times anything is itself, okay? So that's one place that's useful for us. Let's see. The inverse, the multiplicative inverse is very useful. A quick example of that would be something like this. Solving 1/2 x is 5. Well, the inverse of 1/2 is 2 over 1. In other words, I'm allowed to multiply equations by any number that I want as long as I multiply both sides. So I'd say 2 times 1/2, right, is 2 times 5. Right? And this gives me, oh, I forgot my x there, y'all. Sorry about that. It gives me 1x is 10. So multiply by the inverse. Again, an example of this, another great example would be 2/3 x is equal to 6. The multiplicative inverse is 3/2. Multiply both sides by 3/2. So that's going to give you 1 by definition. And here we get 18/2, which is 9. So that's an example of using that property. Again, this is just an overview of some of these properties and why you care. They help us out. Commutative property. The order in which you add or multiply numbers does not change their sum or product. All right, so A plus B is equal to B plus A. You can move things around. Here's an example of this. A person says combine like terms. I know that I can rearrange this in any order that I want to combine these things. This combines with this, and it combines with this. It doesn't combine with this 3x, right? So in other words, I can call this x squared plus 2x squared plus x squared. Otherwise, a person could move them together, right? Any order you want. And then you would have 1x squared plus 1x squared plus 2x squared. I guess my point here is that's what allows you to move things around and combine your like terms, right? It doesn't matter. In other words, 2 times 3 is equal to 3 times 2. Yes, we know that. Order doesn't matter in the way you multiply, okay? So if you see a variable expression, for example, somebody has some goofy thing written like this, xy times 2, feel completely free to call it 2xy. It's also 2yx. They're all the same thing. You can change the order. Typically, you'll find that people put coefficients in the front. By the front, I mean left. And they'll put variables oftentimes in alphabetical order, although that's not wrong not to, I guess, but it's just not typically done. You could say that maybe it's not good form or something like that. Okay, let's move down to this other property. For any numbers A, B, and C, this is distributive. We've talked about this. I don't know if I need to show you this or not. I'll get into that in the videos. This distributive property is super important. That's how you multiply inside your parentheses. Remember, it just means it visits both of them every time. Oh, and that's the last one. Okay, so for the remainder of this video, I've got a really short equation I want to solve, and we're going to start a series of equation solving, and they get more and more complicated as we go. But I don't want to make another whole video just for this really simple one, okay? So we'll start this up in this video, and this will be, well, I call it a review of solving equations. And remember, a mathematical statement that contains an algebraic expression and symbols is an open sentence. A sentence that contains an equal sign is an equation. The expression 3 times the number plus 7, or 3x plus 7, is called an expression. It's not equal to anything. And the minute you put the equal sign, you're saying it is. You assert that this is a true statement. When you write an equation, it is an assertion that something is true. In other words, this says 3 times some number plus 7 is 13. Our job is to find out what that number is. And we'll use these properties of equality to do it. And we'll follow them rigidly. If you don't know the properties, you cannot confidently solve equations. And that is true. Okay, so I wanted to do one simple one, and I've got several here that we're going to work out a series of them. You guys, it's important that we're good equation solvers. All right, and we'll do this one first and finish this video up with this one. Then we'll move down to more complicated cases in subsequent videos. All right, so let's do, I got something bounced off my window out there. I don't know what that was, some kind of bug maybe. Okay, so we got something like this. 6x plus 9 is equal to 4x plus 25. Okay. I don't know if people talked to you about this before, but one way to solve is really what you want x, that's your variable, you want him on one side or the other, doesn't matter, because remember we have symmetry, with a coefficient of 1 equal to a number. And that's called a solved equation. And the steps in doing that is I usually take my variables first. Okay, I want to get the x's on one side of this equation. They're both positive, so I'll need to subtract. And I can only subtract them from what they're like with. So I'm going to say minus 4x. And I'm bringing this way because it will keep things positive, right? Drawing the line. Combine like terms. 6x combined with negative 4x is 2x. Bring down the 9. And don't get sloppy. If you will follow these steps that I'm doing, keep everything, and I brought him down. That's how he got down there, right? All right, now the next move here, some people say divide. Well, no, you want to get this isolated by itself. Division will be your last step, right? And the next move is to subtract 9 from both sides. Bring down your 2x. He's still in the game. I'm just bringing it down. Combine it. That's 0. I don't think we need to write a 0 there. 25 minus 9 is 16. And the final step to solving this would be divide by 2. Why do I know to divide? Because this is 2 times x, and I need to, or you can think of multiplying by the reciprocal, which is 1/2. Right? They're the same thing. So we'll get x is 8 as our solution. Now we got a 1x and an 8. So that's us for that one. Okay. All right. I'm going to end that video with this. We'll check another one in another videos before when it won't be so long to check. And you check by plugging this back into x. But we'll get that in another one. Okay. All right. Thanks for watching. The next video we'll pull the bar up a little higher, a little more complicated. So we'll see you then.